in the following table B is a foreign key referring to the primary key A with on delete cascade option. When we delete the tuple 4 comma 3 from the table, the number of tuples left in the table if it preserves referential integrity is. Here it is given that attribute B is a foreign key referring to the primary key A. That means the values which are allowed under attribute B must be present under A. Other than those values should not be present under B. And so if we delete tuple 4 comma 3, if we delete this one, here the tuples under the tuples in which the value of B is 4 should also be removed. So here if we delete 4 comma 3, even this attribute this tuple should be deleted, and if as we have deleted 2 comma 4, the values the tuples in which the value of B is 2 should also be removed. So we will remove this one also. So if we remove this one, we have to remove 3 comma 9, as 9 is referring to attribute A, as B is referring to attribute A. So as 9 is deleted, this 3 comma 9 should also be deleted. If 3 comma 9 is deleted, here 1 comma 3 also should be deleted. And here 5 comma 4 should also be deleted. Why? Because previously we deleted 4 comma 3. So the value of the tuples in which the value of B is 4 should also be removed. So here the number of tuples left in the table is 0, which is option A. Determine the number of perfect matchings for the graph K6. Here the number of perfect matchings for K2n. K2n is given by the formula 2n factorial by 2 power n into n factorial. Here 2n is 6, so n will be 3. If we substitute the values in this formula, 2n factorial is 6 factorial by 2 power n, 2 power 3 into n factorial, 3 factorial. So if we simplify this, we would be getting 15, which is option A. Here we have to remember this formula. Number of perfect matchings of K2n is equal to 2n factorial by 2 power n into n factorial. Let G be a non-planar graph with minimum number of vertices. Then chromatic number of a graph G is option A 2, option B 4, option C 5, option D 6. Here it is given that G is a non-planar graph with minimum number of vertices. But we know that non-planar graph with minimum number of vertices is K5. And chromatic number of in K5, all the vertices are adjacent to each vertex is adjacent to all the remaining vertices. So here each and every vertex need different color. So here chromatic number is 5, which is option C.
Statements is/are true. Statement S1 is DCFLs are closed under complementation, but CFLs are not. Statement S2 is both DCFLs and CFLs are not closed under intersection. A. S1 only, B. S2 only, C. both S1 and S2, D. neither S1 nor S2. So here as far as the CFLs are concerned, the CFLs are not closed under intersection and complementation both. But whereas if you consider the closure properties, DCFLs are closed under complementation, but CFLs are not. So S1 is true. S2, both DCFLs and CFLs are not closed under intersection. So here DCFLs are not closed under intersection, but DCFLs are closed under complementation. But whereas CFLs, they are not closed under both operations. So both the statement S1 and S2 are true. Option C is the right option. The number of states in minimal DFA which accepts the strings of length exactly 100 over the alphabet 0, 1 is. So here exactly 100 means we will have 0 plus 1, 0 plus 1, total 100 times. You have to write, this is the regular expression. So if you want to accept length 2, the DFA will be like this. This is length 1, length 2, this is exactly 2. But we require to have a dead state which is accepting 0, 1 from the final state. So total it will become 4 states for length 2. For length exactly 100 it will become 100 plus 2. Total 1 or 2 state, because we have to introduce a dead state. Normally without dead state n plus 1 states are required if it is length n, but including dead state it will become n plus 2. For length 100 it will be 100 plus 2, 1 or 2. So option D is right option.
Find the value of 0 to pi cos power 8x dx. We know that 0 to pi by 2 cos power nx dx is equal to n minus 1 by n into n minus 3 by n minus 2 to so on up to k. K is equal to 2 by 3 if n is odd. N is odd, k will be 2 by 3. It is equal to 1 by 2 into pi by 2 if n is even. Here n is 8 even, and here 0 to pi is there, but in formula it is 0 to pi by 2, and we know that integral 0 to 2a f of x dx is equal to 2 into 0 to a f of x dx if f of 2a minus x is equal to f of x, and it is equal to 0 if f of 2a minus x is equal to minus f of x. So here f of 2a minus x is equal to f of 2a is pi. So f of 2a minus x cos of pi minus x whole power 8. So cos of pi minus x is minus cos x. As power is even, it is minus cos x whole power 8, which is cos power 8x. So here f of 2a minus x is equal to f of x. So we can write 0 to pi cos power 8x dx as 2 into 0 to pi by 2 cos power 8x dx. So which is nothing but, as we know that integral 0 to pi by 2 cos power nx dx is, here we have to decrease 1, 7 by 8, and numerator we have to decrease numerator and denominator by 2. So 5 by 6 into, this is 3 by 4 into 1 by 2. If 1 by 2 is there, we have to multiply by pi by 2. So if we solve this one, we would be getting answer as 35 pi by 128, which is option A.